we're going to continue talking about quadratic functions and the directrix and the focus. All right, so giving you kind of a visual here and a step-by-step process, hopefully, of how to graph a parabola using the directrix and the focus and the vertex and the axis of symmetry. If you have x minus h squared equals 4p parentheses y minus k. In other words, if the x binomial is the one being squared, then you're going to have a parabola that either opens up like this if a is positive, or it'll open upside down if a is negative. Your focus now, remember when our vertex was at the origin, what we were doing yesterday, it looked like x squared equals 4py. And you can tell now what's different is this has changed to x minus h squared, and this has turned into y minus k, which has moved your vertex. Okay, not your vertex, I'm sorry. Your vertex will be at h comma k, just like it always has been. Your axis of symmetry, again, when x is squared, your axis of symmetry will be x equals h. Your focus now, and again, if you look, it should make sense to you. Remember, when x was squared, the focus was at 0p. Well, now it's going to be at h. That's not going to change, but the focus is higher than the vertex. So whatever the k value is, you have to add p to that to get up to the focus. The directrix, on the other hand, is the same distance but below. Okay, so to get there, you're going to change it's going to be y equals the k value minus p. And that will give you this horizontal line for your directrix. Again, if p is greater than 0, it opens up. If p is less than 0, it opens down. So our steps, you're going to find and plot the vertex. You can get it right there. You're going to graph the axis of symmetry at x equals h. The value of p, you're going to take whatever's here and divide it by 4, and that will give you the value of p. And then you're already going to know your h and your k, so once you know that, you can get your focus by keeping the h and adding p to k, because that's going to be higher than the vertex by p units. You can find your directrix by subtracting p from k, because that's going to be the same distance below the vertex. See, the distance below and the distance to the focus are exactly the same. Okay, now this latus rectum. So this latus rectum is the length of, if you take 2 points that are directly equidistant from the focus horizontally, that length, whatever that length is called the latus rectum. Okay, and it will be the value, or the absolute value, of whatever is touching the y minus k parentheses. Okay, and so what you do, you figure out that value and you cut it in half. Okay, and you go that far to the right of the focus and to the left of the focus, plot those 2 points and connect your vertex to your latus rectum points, and you've got a good graph. So here we go. It says find the vertex, focus, and directrix of the parabola given by this function. Well, if x is being squared, remember my formula is x minus h squared equals 4p parentheses y minus k. So this tells me that h equals not negative 3 but positive 3, and k equals negative 1. So my vertex is at 3, negative 1. And if I plot that, go over to 3, down to negative 1, and plot that point. Okay? Next, they want me to graph the axis of symmetry, which is x equals h. Again, my x is 3, so it's x equals 3. To graph that, it's a vertical line through the vertex. Done. Find the value of p. And again, in my equation up here, 4p is whatever touches the y binomial. And for me, this says that 4p equals 8. So divide by 4, and p equals 2. Okay? Which then allows me to find the focus and the directrix, because 2 units up will give me the focus and 2 units down will give me the directrix. So for the focus, I keep the h coordinate, which is 3. But instead of keeping the k, I'm going to add my p to it. So if I add p to it, that becomes 3 comma positive 1. So if I graph that, there's my focus. Which, and at this point, you can actually just count. I mean, if you're graphing, the focus is 2 units above, so the directrix is going to be 2 units below. It's just that it's not going to be a point. It's going to be a horizontal line. Okay, but we can do the math. The equation for a horizontal line starts with y equals. Says take your k value, which is -1, and subtract p, which is 2, which gives me -3. And to graph y equals -3, that's it, like I said, it's a horizontal line through -3. Okay, so there's my focus, there's my directrix, there's my vertex, and there's my axis. Notice that my axis and my directrix make a 90-degree angle to each other. Okay, so now we need 2 more points and we're good to graph. This is where the latus rectum comes into play. The latus rectum, that should say the absolute value. I picked the wrong symbol, sorry. Those should just be straight bars. Okay, the latus rectum is the absolute value of whatever's touching the y parentheses. So my latus rectum is going to be the absolute value of 8, which is 8. Now, if I cut that in half, half of 8 is 4, which means I'm going to go 4 units to the right and to the left of the focus. And they want you to calculate the ordered pairs, but come on. Here's my focus. So if I go 1, 2, 3, 4 units right, and 1, 2, 3, 4 units left, that's right there. And then if you see, if I can connect my vertex to my latus rectum points, there is a pretty darn close parabola for that function. Okay? Alright, sorry I animated this and forgot. Alright, so you try this one. They want you to find the vertex, the focus, and the directrix of the parabola. I would like you to graph it too on the side, but just find those 3 first. Hit pause and come back when you're ready. And hopefully you got number 1. If you did not, let's look at y. Alright, here's my equation. And remember, I am looking for the h, the 4p, and the k for different reasons. For my vertex, I want h and k. Well, this says that h is 2, this says that k is 3, and this says that 4p is -16. So my vertex is h comma k, which will be 2 comma 3. My axis of symmetry, oh, they don't want that, they want the vertex, got it. The focus, to get your focus, you keep the same h, but you take your k and you add p to it, because your focus is going to be p units higher than the vertex. To get p, I have to solve this equation over here. So to get p alone, divide by 4, p equals -4. So to get my focus, I'm going to take my h coordinate, which is 2, but I'm going to take my k coordinate, which is 3, and I'm going to add a -4, which is going to give me 2 comma -1 for my focus. Okay, and then my directrix, it's going to be p units, sorry, can't spell, p units lower than my vertex, and it's going to be a horizontal line which starts with y equals, and then instead of keeping your k, it's going to go down by p units, which my p was -4. And if I do oh, sorry, my k was 3, my bad. And my double negative turns positive, and I get y equals 7 for my directrix. If I was graphing this, I've got a vertex at 2, 3. I've got a focus at, where am I at here? 2, negative 1. I have a directrix at y equals 7. 1, 2, 3, 4, 5, 6, 7. And that's a dotted line. Notice the distance between the directrix and the vertex and the focus is the same. Okay, once you get that, all you need is the lattice rectum. Well, my lattice rectum is, in other words, the absolute value of my 4p would be the absolute value of negative 16, which would be 16. Cut that in half, you get 8. And so from my focus, I'm going to go 8 units right. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And I would connect my vertex to my lattice rectum points. And there's my parabola. Alright, you try this one. Push pause, come back when you're ready. And hopefully you got B. If not, let's look at Y. Alright, my H is negative 1. My K is positive 2. And 4P is 6, which means to get P, I would divide by 4, which gives me a P of, if I reduce that, I get 3/2. Okay. Alright, so if I just look here, I'm going to have a vertex at H, comma K. And if I look at all these graphs, negative 1, 2, that's not a vertex, so he's out. Negative 1, 2, that's the right vertex. Negative 1, 2, that's the right vertex. Negative 1, 2, that is not the right vertex. That one's out. So it's between these two, right? Or is that the vertex of this one? No, I think it's between these two. This one's just wider than this one. So what I need to do is, if I can figure out the focus, and let's use a decimal so you don't go crazy. So my P is going to be 1.5. My focus is going to be the same H, but I'm going to go up P units from K. My H is negative 1, my K is 2, plus 1.5 is going to be negative 1, comma, 3.5. Negative 1, comma, hold on there now. Wait a second, what just happened? Oh, sorry, yeah, negative 1, 1, 2, 3.5. Sorry, there's my focus. I apologize, I thought I was trying to find, never mind. There's my focus, okay? My directrix is going to be, again, the same. It's going to be 1.5 units down. That's not really what they're asking for. They're asking for the graph, but there's my directrix, okay? So now all I have to do is use my lattice rectum to get the right width, okay? So my lattice rectum is going to be the absolute value of whatever's touching the y parentheses, which is 6, and half of that, half of 6 would be 3. So from this point, I'm going to go out 1, 2, 3 units and mark it, 1, 2, 3 units and mark it, and this one matches. If you go out up to negative 1, 1, 2, 3.5, and go out 1, 2, 3 units, it's right there, and out 1, 2, 3 units is right there. That does not make that picture. So it's got to be B. Alright? Now, when y is squared, your parabola is going to turn sideways. Alright? If 4p is positive, it's going to open to the right. If 4p is negative, it's going to open to the left. Okay, a lot like when x was squared, your vertex is still going to be at hk. Just be careful. H is still whatever's with x, k is with whatever's with y. But now your axis of symmetry isn't going to be x equals, because y is squared, it's going to be y equals. Because your axis of symmetry is going to be this horizontal line now. Okay? And again, your focus, if this is your vertex, your focus, this time k is going to stay the same. Okay? K stays the same. You're not going to change that. But your focus is going to be to the right of your vertex, so you add p to it. And your directrix is going to be to the left of h, so you subtract your p. Okay? And the latus rectum is, again, is going to be the length of the absolute value of 4p. So you're going to find and plot your vertex, your axis of symmetry. You're going to find p to create your focus and your directrix. Then use your latus rectum to get 2 more points and connect them to get your graph. Easy breezy. Alright, so if we look at an example here, now be careful now. My h would be -2, my k is going to be -4, and my 4p is going to be -8, which means my p is going to be -2. Okay? So that's all the information I need to do all of my work. My vertex is going to be h comma k, so -2, -4, -2, -4, plot it. My axis of symmetry is y equals k, my k is -4. That's a horizontal line through -4, which, you know, it's got to go through your vertex, so it doesn't take Einstein there. There's your axis of symmetry. The value of p I already figured out is -2. So to get my focus, I'm going to take my h, I'm going to add my p, oops, and then I'm going to keep k the same, which is -4, which if I do that math, that's going to give me -4, -4. So if I go to -4, -4, that's going to be my focus. Okay? I usually mark my vertex with a V so I don't connect my focus to my points. Okay, then I need the directrix. I mean, you can do the math if you want, but if I went 2 units this way to get the focus, I'm going to go 2 units this way to get my directrix, which is now going to be a vertical line. But let's do the math. It says x will equal your h value, which is -2, minus your p value, which is -2. And if I do a double negative, minus a negative turns positive, which gives me x equals 0. To graph x equals 0, you go to, x equals, whoa, what did I just do? 2 minus -2 minus a -2 turns positive. And I get, oh yeah, x equals 0. Sorry, I'm just looking at this line going, what did I do? Sorry, yes, x equals 0, which is a vertical line through 0 on the x. Okay? All I need now is some latus rectum points. My absolute value of 4p would be the absolute value of -8, which is 8. Cut that in half. 8 divided by 2 is 4, which means I'm going to go 4 units now, not right and left. We're going to go 4 above and below. Here was my focus. So 1, 2, 3, 4 up. 1, 2, 3, 4 down. Connect your latus rectum points to your vertex, and there's your parabola. Okay? Alright, and sorry, I animated this. Alright, so you try this one. Push pause, come back when you're ready. And hopefully you got number 1. If not, let's look at y. Alright, there's my h, there's my k, there's my 4p. So this tells me that h equals +1, k equals -3. Sorry. And 4p equals -16, which divide by 4 means p equals -4. Okay, Okay, those are really the three things that I need to know to get all my other information. To get my vertex, it's h comma k, so that's going to be 1 comma negative 3. I'm just going to go ahead and graph this as we go, just for practice, even though you didn't have to do it here. So 1, negative 3. My, what else do they want? The directrix. Oh, that was my vertex. So they want my focus. For focus here, your k isn't going to change. You're just going to increase your and decrease your h value, your horizontal value, by p. So to get my focus here, I'm going to take my h, which is 1, plus my p, which is negative 4, and keep k the same, negative 3. 1 plus negative 4 would be negative 3, negative 3. So if I plot my focus, I would go negative 3, negative 3. There's my focus. Okay? My directrix is going to be 4 units the other way. Okay, but again, to illustrate the math, to get my directrix, and again, you're going to look at this for a while and then you'll get the hang of it. It says that x equals my h coordinate, which is 1, minus my p coordinate, which is minus 4. The double negative turns positive, so I get x equals 5. So 1, 2, 3, 4, 5, and that is a vertical line. Sorry, we didn't graph the axis. The axis passes through the vertex. The directrix is parallel to the focus. Okay? Now all I need is the width of this thing, which my latus rectum will tell me. And my latus rectum is going to be the absolute value of negative 16, which is 16. So my latus rectum, half of that, half of 16 would be 8. So from my focus, I'm going to go 8 units up. 1, 2, 3, 4, 5, 6, 7, 8. And 8 units down. 1, 2, 3, 4, 5, 6, 7, 8. And connect to my vertex. And that would be my parabola. Okay, I know we didn't have to graph, but there's your vertex. There's your focus. And there's your directrix. Okay? Alright, in Math Excel, what is it that you're going to have to do? Alright, well first of all, you're going to get all your information. Your vertex is going to be, again, there's my h, there's 4p, there's my k. So h equals negative 2, k equals positive 4, 4p equals negative 4, divide by 4, and I get p equals negative 1. So I have a vertex at hk, negative 2, 4. The focus is going to be, you're going to keep the h the same, and you're going to take your k and you're going to add p to it. 4 plus a negative 1 is 3. And then for the directrix, when x is squared, it's y equals, and you take whatever your k value was, and you add p to it, or you subtract p, sorry, you add p to get the focus, you subtract p, so minus a negative 1. Double negative turns positive, and you get y equals 5. Now, to graph it, you're going to click on this. You're going to choose whatever, since x is squared, you're going to choose the upside right or down parabola, not the sideways one. Okay, set the first point at your vertex. So I'm going to go to negative 2, 4, and I clicked there and let it go. And then you're going to use your latus rectum, which they don't actually ask for, but they need, all you need is one other point to put on there, and the computer will symmetrically put it on the other side and graph it for you. So to get any other point, I mean, you could do lots of different things. One thing is to use the latus rectum. Well, my latus rectum here would be the absolute value of negative 4, which would be 4. Half of that would be 2. So from my focus, sorry, I didn't find the focus. Oh yeah, I did. The focus was at negative 2, 3. From my focus, if I go 2 units this way and click on the mouse, or I could have gone 2 units this way and clicked over here, either one, the computer will finish drawing the parabola for you. Alright, so it says, given a quadratic equation in vertex form, identify the vertex, axis of symmetry, and direction of opening. Well, your A if it's a positive A, it will open up. If it's a negative A, it will open down. If it is, let's see, the vertex is going to be H, comma, K. The axis of symmetry is going to be X equals H. And we already did the direction of opening. Okay? Alright, to convert each equation to standard form by completing the square on X or Y. They're going to give you equations that are a mess. Okay? So what it says to do is it says get the squared term and the matching linear term on the left, the linear term of the other variable and the constant on the right, complete the square on the left by adding half of b squared to both sides, factor the left, PEMDAS the right, factor out 4p, then identify your vertex, focus, and directrix, and then you can graph it. It's going to be a little more complicated, but here we go. The first thing says get the squared term and matching linear term on the left. What I mean is y is squared. So I want that variable squared and the one to the first together on one side. And I want the linear term of the other variable. See how x just has a linear, it doesn't have a square? So I want him and him on the other side. So these two are going to stay, and I'm going to move these two. So minus 12x, minus 12x. That gives me y squared plus 2y minus 23 equals negative 12x. Then I'm going to add 23, add 23. I'm going to have y squared plus 2y equals negative 12x plus 23. So steps 1 and 2 are done. Okay, step 3, we're going to complete the square. Alright, we do that by adding half of b squared to both sides. All I got to do is figure out what half of b is. Well, b is 2. We're looking at the squared term, the one that has a squared and a linear. You're not looking at these two. b would be 2. Half of that would be 1. Square that would be 1 squared would be 1. So what I'm going to do is I'm going to add 1 to both sides, which now gives me y squared plus 2y plus 1 equals negative 12x plus 23 plus 1. You're going to factor, so okay, I added half of b squared to both sides. You're going to factor the left. This is going to factor into a binomial squared. The square root of y squared is y. The sign in the middle is plus. The square root of the end is 1. And it says PEMDAS the right. I can combine like terms and I get negative 12x plus 24. Done. Now, the next step, this is kind of different for us. Okay, the next step says factor out 4p on the right. And remember, on the right, this side is done. This side is good. If I factor out 4p, whatever that is, I promise, whether it goes into this other guy evenly or not, I don't care. Whatever touches x is your 4p. So I'm going to factor out a negative 12. If I GCF out negative 12, to get what's left, I divide by it. That's going to give me positive x. 24 divided by positive 24 divided by negative 12 is negative 2. And there we go. We are now in vertex form, or whatever form they call this. Okay. Which gives me an h of 2, a k of negative 1, and a 4p of negative 12, which makes p negative 3. So I'm going to have a vertex at 2, negative 1. 1, 2, negative 1. To get my focus, when y is squared, your k is going to stay the same, but my h, I'm going to add p, which I'm going to add a negative 3, which gives me negative 1, negative 1. My focus will be right here, which means my directrix is going to be that far on the other side, but let's do the math. My directrix, when y is squared, is x equals, and you take your h, which is 2, and you subtract p from it. So minus a negative 3 the double negative turns positive, and I get x equals 5. So I go to 5 on the x-axis, and I make a vertical line. There's my directrix. All I need now is the width. We didn't graph the axis, but there's always an axis through the focus and the vertex, actually. Okay? So my latus rectum is going to be the absolute value of negative 12, which is 12. Cut that in half, and you get 6, which means from my focus, I'm going to go 6 up and 6 down. So, where am I at? Negative 1, 8, 1. So 1, 2, 3, 4, 5, 6 above. 1, 2, 3, 4, 5, 6 below, and then down to 5. And you connect your latus rectum points to your vertex, and there's your parabola. Alright, let's try another one with the x variable this time. So here's my squared and linear, and here's my linear and constant that need to go to that side. Oops, sorry. Alright, so I'm going to add 4y to both sides. That's going to give me x squared minus 2x plus 9 equals 4y. Then I'm going to move my positive 9 with negative 9. That gives me x squared minus 2x equals 4y minus 9. Alright, then I'm going to complete the square. My b is 2. Half of that is 1. That squared is 1 squared is 1. So I'm going to add 1 to both sides. Okay, then I'm going to factor the left, which is going to be a bino squared. Square root of x squared is x. Sign in the middle is minus. Square root of 1 is 1. On this side, I'm going to combine like terms, and I get 4y minus 8. So I've done all this. Now I'm at factor out 4p, which I don't care whether it goes into the one evenly or not. Whatever's touching, in this case, y, that's your 4p. If I factor out 4, I'm going to have y minus 2 left. And now I'm in this form where I can see that my h is 1, my k is 2, and 4p is 4, which means p equals 1. So I'm going to have a vertex at h comma k, which is going to be 1 comma 2. I'm going to have a focus when x is squared. Alright, when x is squared, your focus is, so it's going to be, you keep the same k, no, you keep the same h, and your k is going to change. So I'm going to keep the same h, which is 1. And my k is going to go up by p units for the focus and down by p units for the directrix, which is going to give me 1 comma 3. There's my focus. My directrix, when x is squared, starts with y equals, because it's going to be a horizontal line, and you take your original k, which is 2, and you subtract p from it, which gives me y equals 1. So if I go to 1 on the y-axis and I make a horizontal line through it, there's my directrix. And now I just need my latus rectum, which is going to be the absolute value of 4, which is 4. Half of that is 2. So from my focus, I'm going to go 2 units to the right and 2 units to the left. Connect those to my vertex, and there's my parabola. Okay? Alright, you do this one. Convert the equation to standard form for parabola by completing the square on x or y as appropriate. Hit pause, come back when you're ready. And I hope you got 2. If not, again, here's my squared and linear that stay. Here's my linear and constant that move. So if I minus 3x from both sides, I get y squared plus 6y minus 3 equals negative 3x. Then I'm going to add 3. I get y squared plus 6y equals negative 3x plus 3. And I'm going to leave some room so that I can add half of b squared. My b is 6. Half of that is 3. Half of that squared is 9. So I'm going to add 9 to both sides. Okay, then I'm going to factor the left. This is going to be a perfect square. The square root of y squared is y. The sign in the middle is plus. The square root of 9 is 3. PEMDAS the other side, I can combine like terms. I get negative 3x plus 12. All of this is done. Then I'm going to factor out 4p on the right, which is whatever's touching x. So I'm going to factor out a negative 3. If I GCF by negative 3, that's going to leave x minus 4. And on this side I still have y plus 3 squared. Well, that's going to tell me that h is 4, k is negative 3, and 4p is negative 3. So if I want to, I'm sorry. I don't know. I was going to graph it for you. But they just wanted the equation. So there you go. Alright, so how do you transform a quadratic equation in standard form into vertex form using the method of completing the square? Well, you put you're going to need to say this in a lot better words than I am, but you put your second degree and matching first degree on one side, and you put the first degree and the matching constant on the other. Then you complete the square and simplify. Okay. To use the vertex and the direction in which the parabola opens to determine the relation's domain and range and decide if the relation is a function or not. They're making this really, really complicated. We've already talked about domain and range, okay? If x is being squared, if 4p is positive, it opens up. If it's negative, it opens down. Domain anytime x is squared. I promise your domain will never be different. It'll be negative infinity to infinity. Now, if it opens up, think about it. Your range is going to go from, this will be your vertex, the bottommost point, that x and y coordinate. That will be your vertex. So basically what it says is your range, if it opens up, is going to go from k to positive infinity. If it opens down, then your vertex is at the top. Remember, that's your hk. Then your range will go from negative infinity, stopping at k, or the y coordinate of the vertex. Okay? And I promise you, if x is squared, it's going to pass a vertical line test, which means it's a function. Okay? Now, what about y? If y is squared, these things open sideways. So now, again, it's kind of different. If 4p is positive, it'll go right. If it's negative, it'll go left. But now your domain is going to be different, and your range is going to always be negative infinity to infinity. Because again, if I'm doing domain, I can block this on the left. I can't block it on the right. It's going to break on through. Okay, so if it opens to the right, the domain is basically going to be the x-coordinate of the vertex, or h, comma, positive infinity. If it opens left, it's going to do this, which is going to go from negative infinity, but stop at h. Okay, and the range, these will go to the bottom to the top forever and ever, so your range is negative infinity to infinity. Now I promise, when y is squared, it's not a function, ever. It won't be, because it won't pass the vertical line test. Alright, so it says, use the vertex in the direction in which the parabola opens to determine the relation's domain and range, and is it a function? We don't even actually have to graph it. Alright? If I've got here, let's see, I've got y squared, I'm going to put my square and my linear on the same side. So I'd have y squared minus 6y equals, oops, plus 6y, sorry. My bad, I better not do that in my head. I'm going to move this over. So that's going to give me y squared plus 6y equals x minus 5. Okay. So I'm going to complete the square. And I'm going to do that by adding half of b squared. My b is 6, half of that is 3, square that is 9. So I'm going to add 9 to both sides. And this side's going to factor into y plus 3 squared. Combine like terms equals x plus 4. If we factor out 4p, which is whatever touches x, if I factor out a 1, I'm still going to have x plus 4. So, y is going to be squared. My 4p is positive, which means this thing is going to open up, correct? And we have a vertex. H is negative 4, k is negative 3. So my vertex is negative 4, negative 3, which means that's this point right here. Okay? So as far as my domain goes, I can block it on the left. It doesn't even start until negative 4. And it goes forever and ever and ever because it's going to break on through that side to infinity. Now, my range, on the other hand, if they open sideways, I promise you, your range is always going to be negative infinity to infinity. Because I can't block the bottom or the top. It's going to break on through and keep going down and break on up and keep going right. Alright, so again, let's do the same thing. This one's already written in vertex form for me. X is being squared and 4p is negative, so it's going to open down. And my vertex is going to be at h, which is 1, k, which is 3. So this vertex is at 1, 3, and it opens down. Which means for my domain, I can't block it right to left. That's going to be negative infinity to infinity. But my range, I can't block the bottom, so it starts at negative infinity. But I can block the top, and it goes no higher than k, which is 3, and includes it, which is a bracket. Okay? Alright, you do this one. Hit pause, come back when you're ready, and hopefully you got 4. This one's written in standard form, which is what we're used to working with all last week. If your squared term is positive, written in standard form, this thing is going to open up. Okay? Now, your vertex from here, ooh, this shouldn't be in this one. Interesting. Okay, I'm going to kind of lead into what's coming up tomorrow. Alright? But if you need to find the, oh no, we know how to find the vertex. Never mind, I'm thinking we're behind. To find your h, you take negative b over 2a to get your k, minus ah squared. So to get my h, it's going to be a negative 10 over 2 times 1, which is going to be negative 10 divided by 2, which is negative 5. My k is going to be my c, which is 26, minus my a, which is 1, times my h squared. Well, negative 5 squared is positive 25, times 1 is 25, 26 minus 25 is 1. So I've got a vertex at negative 5, 1. So, for domain, I can't block the right or left. It goes from negative infinity to infinity. But the bottom to the top, I can block it on the bottom. It's not going to go any lower than 1. Okay, but it's going to break on through and go all the way up to infinity. Alright, is this relation a function? Hit pause, come back when you're ready. And hopefully you got no. I don't have to graph it. I don't have to, if x is squared, it's going to open up or down. Those will always pass the vertical line test, so those are functions. When y is squared, it's going to open to the right or to the left, which will never pass vertical line tests, so those are not functions. Okay? Alright, and hold on just a second. Okay, and we're back. Sorry, had to eat dinner. Alright, an engineer is designing a flashlight using a parabolic reflecting mirror and a light source shown in this figure. The casting has a diameter of 4 inches, so from one end to the other it's 4 inches, and a depth of 2 inches. What is the equation of the parabola used to shape the mirror, and at what point should the light source be placed relative to the mirror's vertex? Okay, well, first of all, if this is 4 inches, then if you cut this in half and you call this 0, 0, then from 0 out to this point, which they said would be half of 4, which would be 2, right? And 2 inches tall would put that a point on the parabola of 2, 2. We now have an xy coordinate that falls on this parabolic path created by this flashlight. So we can use that to solve and figure out what P is. Okay, so if I use the point 2, 2, and I use this equation, and I change my x to 2, and my y to 2, that's going to give me 4 equals 8p, divide by 8, and p equals 1/2, which means that the light source should be placed a half a unit above the vertex, whatever my units are measured in. I didn't read it very well though. They also said they want the equation of the parabola. Well, if I know p, plug it in. So I have x squared equals 4 times 1/2 y, which gives me x squared equals 2y. There's the equation for the parabola. Okay? Alright, you do this one, hit pause, come back when you're ready, and hopefully you got 1. If not, let's look at y. They were nice enough to actually draw the picture for me. It says it had a diameter of 12, which if you put this at 0, 0, made this point 6 feet out. Okay? And since the depth was 3 feet, this point right here would be 6, 3. So if I use my equation, x squared equals 4py, and I use this for x and this for y, I'm going to have 6 squared equals 4p times 3, which gives me 36 equals 12p, divide by 12, and p equals 3. So the focus should be placed 3 feet from the base, or the light. Alright, so describe one similarity and one difference between the graphs of y squared equals 4x and y minus 1 equals 4 times squared equals 4 times x minus 1. This guy, there's no parentheses, so he's going to have a vertex at 0, 0. Whereas this guy, there are parentheses, h equals 1, k equals 1. It's going to have a vertex at 1, 1. There's one difference. One similarity is that this, because 4p is positive, is going to be a parabola that opens right. And this, since 4p is positive, is also going to be a parabola that opens right. So they both are going to, there's one similarity. They both open right. One difference is they have different vertexes. Okay? And we are at homework, which means we are